Okay, guys, I'm coming to you from a hotel room in Coffs Harbour tonight. I've had a curry, I've had a Cold Rock ice cream. I've got a roommate who I've just met tonight who now thinks I'm sitting out here talking to myself. So we've established I'm weird enough. We can roll on with the lesson. So today's lesson is about calculating medical doses. So this takes many forms. The first thing we have to think about is that generally when we're talking about medical doses, we're talking about milligrams. And sometimes we need to convert from milligrams to grams. So just like a millimetre is a thousandth of a metre, a milligram is a thousandth of a gram. So if we just do some basic conversions first, so if we're going to convert 300 milligrams to grams, we're going to have to divide that by 1,000. Okay, like so. Now when I divide by 1,000, I move the decimal place 3 times. 1, 2, 3. So we end up with 0.3 of a gram. Okay, similar to do 87 milligrams. Once again, we have to divide by 1,000 to get from milligrams to grams. So 87 divided by 1,000, well, that's going to mean the decimal place is going to move 3 times. So we're going to be looking at 0.87 grams. Sorry, 0.087 grams. It's been a long day. And then finally, if we had an amount in grams we would convert to milligrams, we've got to do the opposite. We've got to multiply by 1,000. So the number's going to get bigger. So if we take that 0.5 and multiply by 1,000, it means we have to move the decimal place 3 times again, but in the other direction, which is going to give us 500 milligrams. Okay. Moving right along, one of the formulas that will come up a lot here, or actually the groups of formulas that come up a lot here, will be calculating dosage for children. So there's 3 different ways to do this that are provided in the syllabus, and one is based on the age of the infant in months, one is based on the age of the child in years, and one is based on the weight of the child. And obviously there's each formula has a different specified use. So Fried's formula is really designed for people between 1 and 2 years old, Young's formula from sort of 1 to 12 years old, and Clark's formula generally for any child. They each come up with different results because they get there a bit differently. The important thing to remember, particularly with Young's formula, is if the age of the child is in years, and we're talking about a child that's 30 months old, so 2.5 years old, we don't put in 2 or 3, we put in 2.5. So if they're 1 year and 3 months, that means they're 1 year and a quarter, so 1.25 years old. Okay. So the first question here we've got an 18-month-old who weighs 10 kilos and they're required to get a painkiller. The adult dose is 20 mils. So what dose is required for the child using each of these formulas? So firstly, using Fried's formula, we've got to put the dosage is equal to the months, so 18 months, times by the adult dose, which is 20, and over 150. So once we work that out, we end up with 360 over 150, which is 2.4 mils. Get rid of all of that. There we go. Okay. Now the next one is Young's formula. Like I said before on the previous page, this asks for the age in years. 18 months isn't 1 year, it isn't 2 years. And there's a big difference between a 1-year-old kid and a 2-year-old kid. There's a difference between big difference between a 1-year-old and a 1.5-year-old. So it makes a difference which one we choose here. So we have to actually say, well, that's 1.5 years. So our dosage in this case is 1.5 times by the adult dose, which is 20 mils, and then we divide that by the years plus 12. So that's going to end up with being 30 over 13.5. Obviously, you could have just put this into the calculator and not had to go to this step, and that's going to give us a dosage of 2.2 mils. So somewhat similar, but a little bit different. Now, Clark's formula is based on the weight. Up until now, we haven't used the fact that the weight here is written down as 10 kilos. So factoring into Clark's formula, we've got a dosage of 10. We've got to work it out by taking 10 kilos and multiplying that by the adult dose, which is 20 mils, and dividing that by 70. All right, which is going to be 200 divided by 70. And when you plop that into your calculator, you're going to end up with 2.86 mils, so a little bit different again. All right, so in this next question, we're being asked once we know how much they've got to take, well, if we're talking about a liquid medication, on the bottle it'll say what the strength is per 5 mils or per 10 mils. So this particular question we're being asked here is how much, if we've got to have 1,000 milligrams of a mild painkiller and the medication says that every 5 mils has 100 milligrams, how many mils of medication we need to make sure we get that 1,000 milligram prescribed dosage. And we can just use this formula here, which is the volume required equals the strength required over the stock strength times by the volume of stock. So to see what that looks like, so if we take the volume required, now our strength required is 1,000 milligrams. That's how much we need, and there's 100 milligrams in the stock, right? Times by the 5 mils that comes in that stock. So when we work all that out, we're going to end up with 50 mils of it. Now the other way to do it is to use what's called the unitary method, and I've sort of stepped this out into a whole bunch of steps. It's not really that complex. But if we start with this basic idea of saying, well, 5 mils equals 100 milligrams. All right, so if 5 mils equals 100 milligrams, well, how much does 1 mil equal? All right, to get from 5 mils down to 1 mils, what do we have to do? Well, if we follow this little line here, we had to divide by 5. Well, if we had to divide this side by 5, by now we should be used to the fact that anything we do on one side of the equal sign, we have to do on the other side. So it means we should have to divide this side by 5 as well. All right, so if we divide 100 by 5, we're going to end up with 20. All right, I'm just going to roll down here a bit. There we go. Okay, so now we've got 1 mil equals 20 milligrams. But what we actually want to know is how much does 1,000 milligrams equal? So that's what we need to know. We need to know, well, what happens when it's 1,000 milligrams? So to get from 20 to 1,000, what do we have to multiply that by? And we can do this just by putting in 1,000 and dividing by 20, and that's going to tell you that we have to multiply by 50 to get to there. So that means we're going to have to multiply this side by 50 as well. So that leaves us with 50 mils. So 1 mil times by 50, 50 mils is going to give us 1,000 milligrams, and you can see that the method is the same. This way seems more complicated, but it's an easier to remember process than trying to remember a formula. But whatever works for you will work, unless you're asked to do it a specific way. Okay, so this is the same question again, except this time we're talking about tablets. So the formula changes a little bit because it's going to give us an answer that's going to work out in tablets. So we've got a patient prescribed 750 milligrams of medication, and each tablet contains 500 milligrams. So once again, we just take this volume required, we take the strength required, which is 750 milligrams, we divide that by how much is in one tablet, and that's 500 milligrams, and when we plug that into the calculator, we're going to find that that equals 1.5. So in other words, 1.5 tablets is going to give us the dosage required. Using the unitary method, as before, as a train rushes past my window, 1 tablet equals 500 milligrams. Well, we want to know what 750 milligrams is. So if we divide 750 by 100, we're going to say, well, it's 1.5 times bigger. So effectively what we've done here is we've multiplied this by 1.5. So in order to work out how many tablets we need, we just need to multiply this side by 1.5 as well, which gives us that same answer of 1.5 tablets. Okay, so we've a situation where we might be in hospital if we're a nurse, and a patient has to receive 1.5 litres of fluid over 8 hours. So what's the required flow rate in millilitres per hour? So the first thing I've noticed about this question is it wants an answer in millilitres, but it's given me information in litres. So the first thing I'm going to do is I'm going to say, well, let's get our units right at the start. So if we're starting with 1.5 litres, let's convert that to millilitres. We've got to times it by 1,000, so we're talking about 1,500 millilitres. So once again, using our good friend the unitary method, we know that in 8 hours, we've got to get 1,500 millilitres of the fluid. So let's say, well, we want to know how much it is in 1 hour. So to get from 8 hours down to 1 hour, well, we had to divide by 8, didn't we? So that means if we divided by 8 on this side, we have to divide by 8 on this side. So if we take 1500 and divide it by 8, we're going to end up with 187.5 mils. So therefore, the flow rate is 187.5 millilitres per hour. And the last little question here, and the last question in algebra, is a little bit of a curly one. So it looks like a simple question regarding the dosage, and we've been given the dosage formula we need to use there, which is Clark's formula. There's a little bit of a curveball thrown at the end that once we work out the dosage, we've got to work out how many tablets that'll be. So let's start from the start. So we just factor into our dosage equation the figures we were given. So we were told it was a 35 kilo child, so that goes in there, the weight in kilos. The adult dosage is 3,150 milligrams per day. Sorry, 3,150 milligrams, and we divide that by 70. So once we plug that into our calculator, that's going to give us a total of 1,575 or 1,575 milligrams. All right, but that's not the answer because we weren't asked how many milligrams, we were asked how many tablets. And the question says that each tablet contains 525 milligrams, so we need to work that out. So just grabbing that formula we used, we could use the unitary method as well, but for this case I just grabbed that formula we used, so the volume required equals the strength required over the stock strength. So the volume required is going to be strength required. We need to get 1,575 milligrams of the drug. Each dose contains 525 milligrams of the drug. So we just put those together and our answer is 3. And if I scroll down here, therefore 3 tablets to get that dosage. Now, what that means is we're now at the end of the algebra unit and we can start talking about earning money, which we will do on Friday.